Hello again, ladies and gentlemen. All right, I'm here to give you the solutions to this homework. Okay, it was pretty tough. I saw some of you had a little bit of trouble, and I kind of knew that you would. All right, these are not easy. All right, so just you got to be careful, and I'm going to give you the solutions the way I see them, and hopefully you're able to hopefully make some sense out of it. Okay. Anyway, this first question, a lot of you got it right, which is cool. There are 8 triangles in this diagram. Okay, you've got the big one. Okay, that's one. And then you've got the 3 that you see here. This would be 2, 2, 3, and 4. Okay, 2, 3, and 4. Okay, and then we also have 5, 6, and then the 2 that we were proving common to each other, 7 and 8. Okay, so there are 8 triangles in that diagram. Okay, so looking at this first one. Okay, looking at the givens, I know that BD is congruent to BE. Okay, and I also know that DA, this segment, is congruent to EC, that segment. Okay, but if I look at A, I've got the proof statement, A is congruent to C. I've got 2 choices, really, of pairs of triangles to prove congruent to each other. Okay, I've got these 2, 1, 2. See where I put those little dots? Okay, those ones. Only I've got a side, and I could get those vertical angles there at F, but I don't have any way of getting any other parts. Okay, so those are not going to be the triangles. However, if I look at this triangle, okay, I'm going to erase all these marks in a minute, but this big triangle and this one, okay, if you prove those 2 triangles congruent to each other, then you can say by CP/CTC, angle A is congruent to angle C. So that's what we're going to do. Okay, so I see I've got those 2 BE and BD. That is one side of each. That's the short side of each. And then I've got those 2 pieces that I can put together using addition to get this side. That would be the long side of BDC. Okay, and this side would be the long side of BEA. Okay, so I got to use addition, partition, and substitution to get those together. And then I can use reflexive on angle B. Angle B is congruent to itself. So then I would have side, angle, side. So that's what I'm going to do. All right, so starting here, I'm going to put in my 2 givens. So I'm going to put 1, I'm going to put BD congruent to BE. And I'm also going to put in DA congruent to EC. Okay, and my reason will be given. Okay. Now, for step 2, well, I've already got BD and BE. That's one side. Okay, now I got to put those together to get my other side. So I'm going to do 2. I'm going to use addition. BD plus DA equals BE plus EC. Okay, and that would be the addition postulate. Okay, once I've done that, I can say BA equals BD plus DA, and I can also say that BC equals BE plus EC. Okay, and those, since those are basically the whole is equal to sum of the parts, that is the partition postulate. Okay, so now I've got my now I've got to do my substitution so that I can actually say that BA is congruent to BC. Okay, so that will be by substitution. Okay, and now I've got my 2 sides. And now 5, we've really only ever been using reflexive postulate on sides, on segments. Okay, but it's just as true for angles. So I can say angle B is congruent to angle B. Okay, and I can use one letter because it's the only angle there. Okay, so so I can use one letter. All right, so I'm going to say 5. That is by reflexive. And now I've proven those 2 triangles congruent to each other by side, angle, side. So I can say BEA triangle BA is congruent to triangle BDC. Okay, and I used side angle side, congruent to side angle side. All right, and the final step, of course, is CPCTC. 7 angle A is congruent to angle C. Okay, 7 C P C T C. And feel free to use that abbreviation. Okay, if you see me do it in a proof, you can do it on your proofs. Okay. Okay, so that's that one. All right, so let's take a look at number 2. Okay, so TP. Now again, I've got a bunch of triangles here, a bunch of pairs, a couple of pairs. Okay, and then one extra one there. TP, that tells me this segment is congruent to this TQ. Angle SPQ, that's this big one, is congruent to RQP, which is this one here. And then by reflexive, I've got this. But I'm trying to get SPQ, okay? So this TP and TQ are not the entire side, okay? So maybe we won't use side angle side. What I can do is in this triangle, okay, since I've got those two congruent sides, I've got that this angle is congruent to this one, okay? And then I will have angle side angle, okay, in each triangle. Okay, so let's write this one now. Okay, so my first given, TP is congruent to TQ. Given. Two. Okay, because of that, I can say angle TPQ is congruent to angle TQP. Okay, that was 2 in a triangle. The angles opposite congruent sides are congruent. Okay. Okay, the angles opposite congruent sides are congruent. Okay, so now I've got that angle. Okay. Next, I can write angle SPQ. SPQ is congruent to angle RQP. Okay, that's given. Okay. Four. PQ is congruent to QP. Okay, that is by reflexive. Okay, and now I've got all my parts. I can say 5. Triangle SPQ is congruent to triangle RQP. And I did that using angle, side angle, congruent to angle, side angle. Okay, and now for number 3. Okay, so again, we've got a couple pairs of triangles we could use to get 1 and 2 congruent to each other. Okay, EF is here and GF is here. Okay, and DF is this entire side is congruent to HF, this entire side. Okay, so my givens are pointing me towards those two bigger triangles, FDG and FHE. Okay, those two big triangles. Okay, because then again, I can say angle F is congruent to itself by reflexive, and I've got side angle side. All right, so that one's a little bit more straightforward than the others, but there it is. All right, so here we go. So I'm going to state my two givens. EF is congruent to GF. Okay. And 2. Oh, I can just stick this in the same statement here. Okay, DF is congruent to HF. Okay, and those are basically my two sides. Okay, 2 angle F is congruent to angle F. Oh, I butchered that one. Let's see. All right, angle F. All right, it's 2. This is 2. This is reflexive. All right, so reflexive can be used on angles. Okay, now the two triangles are congruent to each other. So which triangle? So it's a triangle. I'll say DFG is congruent to triangle HFE. Okay, and I did that using side angle side this time. Okay. Okay, and 4 angle 1 is congruent to angle 2. Okay, again, now this is C, P, C, T, C. Okay, so that's it. All right, so the key to overlapping triangles is just being able to spot which two triangles need to be proven congruent to each other. And you can do that by looking at what you're given, which triangles where your givens allow you to prove congruent. So that's it. All right, we'll see you next time.